building a trivia command line app, right? Our trivia command line app, we started building it yesterday. It's a macOS command line tool app. And we decided to build this app using object-oriented programming, which is the pillar of our programming career here going forward, right? There's two concepts in Apple, or two concepts that you could basically be using, principles for building an application. One is object-oriented programming, which would be the fundamental pillar here. And the next one is protocol-oriented programming, which Apple introduced along with Swift, right? Protocol-oriented programming will do some of it, right? But the majority of our programming here will be object-oriented based. What does that mean? I have some game I wanted to design. I don't start with a protocol. Protocol-oriented programming starts with a protocol. Here, I start with some struct or class, right? In our particular object, we have a question. Where do we get the question from? We get the question from our dictionary of questions. If we go over to our trivia data, right? Here we have a struct called trivia. Inside trivia, we have an array of dictionaries. And each of those dictionaries hold a question, right? So the open square bracket, close square bracket, is one element in that array, right? I think our array had 10 elements when we ran it yesterday. Actually, let's run it now. So Command R, and we should have a print statement showing the amount of elements we have in that particular array. So here we have 10 elements. So where I highlighted that box there, that gray box I highlighted, we have 10 of those in that particular array. Everybody with me? We have 10 of those, we have 10 questions, right? So each of those, we say it's a question, it's an element, it's a dictionary. So in that case, we have 10 dictionaries in our array. Everybody with me? We took a step back, we said a dictionary is not enough to model an object. I can't say dictionary here, dot question, right? I want to know my answer. I want to know my question. I want to be able to access this dictionary here very easily. How can I do that? I could use an object. I could use a struct. I could use a class to model that, right? So yesterday we said, hey, maybe we create a question struct or a question class. We created a class to show what a convenience initializer looks like. But at the end of the day, we'll probably go back to a struct because a struct is easier. It's smaller, less memory, right? All that stuff there. We saw all the overhead a class creates of inheritance and all that stuff there, right? But we started with a struct. We changed it to a class for convenience initializers. Either way, class or struct. We said it's a question. A question has a question prompt. So the first key here, we took and we modeled it. We say it's going to be some property, which is a data type string. We also said correct answer is the second property. So here we have 5 properties: question, correct answer, choices, a fact, and a trivia type. So on each question, we could say, get me your correct answer, right? This is the better way to program as opposed to having a dictionary where you have to, each time you want something, use optional binding or whatever it is to query that. That's inefficient. You have an object, you could move an object around. You could pass an object in a function. You could return an object. You could return a question, right? That question object becomes more versatile. Everybody with me? So let's go to our question here. So if you go to question.swift, we have our question here. Our question has 5 properties. We have a question prompt, a correct answer, which is a string, choices, which is a string, fact, which is a string, trivia type was a string, and we said, wait, maybe trivia type should be its own type. Maybe it should be an enum. Why did we choose an enum? We chose an enum because our trivia will only have a finite amount of answers or choices. Our game will only have a finite amount of choices. It could be a movie trivia the user wants to play. The user might want to play a sports trivia game, right? So based on what the user says at the read line, we take one of those trivias from our enum and set our array. So far, so good? Great. What else do we have here? So we have our data we spoke about. We have our enum trivia type. We have the game. That's where all the game logic will be. We had some to-dos. We'll go over those to-dos today. As a matter of fact, who actually finished all the to-dos? Attempted. That's good. Attempted. Attempted is good. Attempting is good. Attempting is good, right? Attempting is good. That's what gets us there. Great. And then we had our question, which we just reviewed, and we had our main.swift here. The main.swift, as we get into iOS development, main.swift here basically is like a controller, right? It's like the controller that gets the data. It presents a print statement to the user, right? So that here is like the glue between our data and the logic of the game, right? The big logic is the game, get me questions, and the main.swift is like the heart of that game. Everybody with me? So basically, if we did this correctly, at some point in Unit 2, we could revisit this project, keep all the files we have here, and basically remove main.swift or import the 4 files, trivia data, trivia type, game, and question, and be able to make an iOS app. Because by itself, it should work if we did everything correctly. If we do not add any game logic in main.swift, which we shouldn't, right? If we don't do that, that will be very portable to an iOS app. Everybody with me? Because the heart of the game is in the game. The question is just a model question. Our data is just data. So that becomes very portable. So that's why if you do your app in an object-oriented manner, it doesn't matter what UI you have. You could have a watchOS app from this. You could have a macOS app from this. You could have a command line app from this, right? If you make your objects just do one thing. That object, whatever that object is, our game should just have game logic. Our question should just have the question logic, right? So far, so good. I'm sorry?
We are in Unit 2.
Yeah, when we move to Unit 2, we don't have main.swift. We have a view controller, which is the controller of the application. We have no main.swift there. Main.swift is a command line only thing. Cool? But we will have like a game.swift or whatever model we have in iOS. So far, so good? Our UI here is the console, right? That's what main.swift presents us. But when we go to iOS development, we have the simulator or our devices as that UI. So far, so good? All right. Very good. So we built our app. We have no errors here. Let's use the actual README to go ahead and complete the parts of it. So if we go back to the README, it says the first challenge was to change in the trivia type, right? We said an enum with trivia options, which we just saw. We're talking about trivia type. Make sure you have trivia type open. It says make trivia type a raw value of string, right? What does that mean, Amini? What does that mean here? What am I doing? What's the syntax for that? So enum trivia type, how do I go ahead and assign a raw value of string to it? What's that? Everybody? Right? So here we've converted our trivia type to a raw value of type string. Everybody with me? So currently all our cases here are now strings. Right? So if I say .raw value on movie trivia, it will be movie trivia as a string. Everybody with me? If I was to say change it to an integer, then this will be an integer. In that case, what would be movie trivia.raw value? 0, right? Not 1. We count from 0. If you want to make it 1, you could explicitly make it 1 like that, right? That would explicitly make movie trivia 1. What would music trivia be? 2. Very good. So this is string. And at that point, we could take out our to-do here. Okay, cool. So let's go back to our README file. Yes?
Is trivia type a raw validation or just has a raw validation?
It has a raw value of string.
Oh, okay.
Yeah, so trivia type as a raw value string. Cool? All right, so here we could say raw value, movie trivia dot raw value, and we would get back the string movie trivia like that. Cool? Any questions? Okay, let's go back to the README. So we're done with trivia type for now. The game says, write the following properties. A questions array property. What type is questions array? Let's go create it. So in the game, it says, create a questions array property. I start out by creating some questions array. What type is it? What's the syntax for that? Sarah? What am I typing in? I'm creating a questions array property. Question says a questions array property. Write the following properties. A questions array property. So the square bracket, right? What am I putting inside the square bracket? What's that? Like the questions, like, so question, like the question type, right? Everybody agree? Question. Everybody agree? Right? So here I have an array of questions. So far so good? Not an array of strings, but an array of questions. And the question is coming from our question struct, right? This is, let me go back. Sorry for back and forth here. But if I go back to questions, this is my array of questions. Everybody with me? So far so good? Okay. So here we have an array of questions, and we could basically copy this step here, remove the to-do, and paste it right above so we know what this is. So this is a property. What type of property is this? Is it a type property or an instance property? Chelsea? Is it a type? You said type property. Jahid, what do you say? You say type property, right? Lilia, is it a type property or an instance property? Instance property for Grimace, right? Okay, cool. So this is an instance property. Everybody with me? We do not have the static keyword here. It's not a type property. Type property has the static keyword. I would have static var. But here, this is an instance. If we say create an instance property, this is an instance property. It doesn't have static. It would be a type property. Exactly. Next one says create a score property. Let's go ahead and do that. So here, create a score property. I'll say var score. What type should score be? What should I assign that to? An int, right? So here I could just say 0. That's valid. If I say 0, what type is it? It's an int, right? Okay, cool. So this is, and what type of property is this? Type method or, type property or an instance property? Instance property. Next up, we have total questions property here. Yeah. We could do it both ways, right? It's good to do it both ways and to know how to do it both ways. In that case, we don't want to instantiate a game with the arguments. We just want a game to be empty. When they start the game, it's just going to be game, open parents, close parents. That's it. They're not going to put the score because that's kind of weird, right? Like to let the user say what score they want to start with. I would start with 100, right? But good question, very good question. Cool. Okay, so here we'll have a total questions property. Let's go ahead and do that. Total questions. Send that to 0 as well. Remove 3. At this point, we're done for now. Let's double check our README before we say we're done for now. Keep track of. Okay, so let's go to the README. It says, oh, number 4. Look at that. Somebody just put that in there. A computed property, we haven't spoken about that. That's good. A computed property has more questions that returns a bool as to whether or not the questions array is empty. That's something new. When you see new things, either the first thing you do, if we haven't shown it in class, again, we can show everything in class. If we haven't shown it in class, simply copying it into Google is a good start. What is computed property? What does that mean? So you copy it, you place it into Google, you put Swift after it. Right, so copy what computed property is, paste it into Google, put Swift after it, press enter. And look at that. I got the Swift programming language to be the first choice. I'll click on that. And here I see properties, that's great. I see stored properties. We know what that is. We've seen that before. So far so good. We saw stored properties very early. This is a stored property. If you go back here, this is a stored property. It has a default value. Right, so this is a stored property. It's storing a value. It has a value. Stored property. There's a value stored in there. Total questions is also, yes, very, very good. So Margaret was saying total questions is also a stored property. Do we agree? Do we agree? Very good. Now let's go back to our documentation on properties here. So we see stored properties. We're still looking. Lazy stored properties, we'll come back to that at some point in Unit 2. There's just so many things. If we start showing you guys those things, you'll be like, what? How can I even know those? How can I remember? Right? How do I know when to use? All those questions will come up. So we'll use them as we go and as we need them. So we have lazy stored. Look, we have computed properties here. Look at that. All right, so we could read through it. We could see what a property looks like. Here we have a property center point, right? So that's a computed property. It computes a value, and it returns us whatever that result is. So that's exactly what we'll be using. A property, its job is to calculate some value and return us whatever that value is. So let's go use it in our code. So here we need a computed property for has more questions. So let's go and create that. So right below our total questions, we'll create has more questions. It's a property. We'll type annotated using the colon. What is it returning? What type? A Boolean, right? We said that in the README. Sorry. The README said returns a bool. Very good. So here we have our colon space bool. Then we have open curly, close curly. We haven't seen that before, right? So here, the compiler is already telling us stuff. It's a computed property, right? Must have accessors specified. In our case, we only have to return something. So that's like getting a value, right? So the accessor we'll be using here, accessor is available in Swift are getters and setters. In our case, if we're doing it based on that syntax here, we'll be just returning some value. In other words, we'll just be getting a value, right? So we'll only be getting a value. It's a getter. So here we return, what's the question saying? Return whether or not the questions array is empty. How do we find out if an array is empty? What's that? Right, so that is empty according to what Matrix is saying. So on our array, questions array, we'll return questions dot is empty. In our case, we'll make it false. So if this is false, then there's more questions. The not here, if I do not have the not symbol, return questions is empty, returns true if it's empty. That doesn't help us, right? Our question says has more questions. Are there more questions? So this is true only if there's more questions. In other words, if it's not empty. Everybody with me? If it's not empty, that means there's more questions. So far, so good. If it's not empty. By not empty, I mean explicitly not empty. That's the not symbol. N-O-T, not. So here we're using the not symbol to negate or change or alter or toggle the current value. So in that case, if the current value is true, which is it's true here, everybody agree? This here, questions is empty, returns true if it's empty. So far so good? Returns true if it's empty. So far so good. But what we want to do is return false. Everybody with me? So you negate this here. So return, if there's more questions, then it's not empty. That's how you read it. Not, the not here, not empty. Just negate it. Cool? So that here is a computed property. Computed property. Yes. It computes something. So here, that's a computation. And it just returns the result. Yes? Whoever called it. So when we say, again, what type of property is this? I mean, it's a computed property, but do I call it on the instance or on the type? On the instance. So it's still an instance property, correct? So when I create my game, I say game.has more questions. And it returns true or false. Cool? So the way I use it, again, it's still an instance property, right? Exactly, exactly. Does that mean you can continue on your own now? We have enough to go? Look at the meaning, like, good. Okay. All right, so here we have an instance property, and the way we would use it, Chelsea, example, we have a game instance. We say game.has more questions, like that. And it would return us, it would return true or false. So we know whether to stop the repeat while or not. Everybody with me? We're going to have some repeat while to get more questions. We see where we're going? We have some repeat while to get some more questions. When I have no more questions, I'm done. Right? So repeat while there's more questions. Everybody with me? And when there's no more questions, we remove all the questions from the array. We stop the repeat while. We're done. If there's currently, we only have 10 questions, right? Of those 10 questions, not all are the same trivia type. I think we might have 4 movie types or something, whatever. So we'll pull out, if the person selects movie, we'll pull out movie. Movie has 4 questions. We'll keep asking questions 4 times, assuming there's 4. So far, so good? And then at the end of the 4, we stop, we give them some score, and we tell them if they want to play or not, if they want to keep playing. Make sense? All right. Great. Any questions about computed properties? This is how it's used. A next way you could use it, for example, if you have a fellow has a first name, a last name. You could simply write a computed property that's full name, right? So it would be something like this. I could write a computed property on fellow called full name. This is just to show us what we could do. The current values. Current values are whatever you need to compute. It's an instance property. You call it on the instance. It returns whatever valuation, whatever logic you want it to do. It just needs to be that type. That type, in our case, a string. I could return any string. What I put into the curly brackets. In that case, if we have a first name, assuming that we have a first name, just keep that there for illustration purposes, right? So illustration purposes to demonstrate using computed property on computed property to return a full name, right? So here, assuming we have like a first name, like that, first name equal to, and we have a last name. Great. And we were told, hey, go ahead and use first name and last name and return me the full name. Everybody with me? So I have a type, it's called fellow, for example. I say fellow that first name, great. I say fellow that last name, awesome. But I want to have some property to say fellow that full name. Everybody with me? Right? Fellow that full name, in this case, I'll just say fellow that full name. It gets me the full name. I don't care how it solved the full name, but it returns me a full name. I want it to return Alex Paul. I do not want to hard code Alex Paul or first name, last name everywhere in my code. Right? Assuming you have code, you have like 10 files or 100 files everywhere, and the only way you do full name is concatenating it. Everywhere in the code, you have first name plus last name. That's not the best way to approach this. The best way to approach it is to have a computed property on your type called full name, and you just say my instance dot full name. Everybody with me? As opposed to hard coding everywhere, first name plus last name. You see where we're going with that? Yes? That would be better than using a function somewhere else. Having a property on the type is better. Because your type, dot full name, that's it. As opposed to doing this everywhere in your code, like say full name, for example. You do like first name. It's probably going to give me an error anyway, but first name plus last name, like that. You would have to do that logic everywhere in your code. You see where I'm going with that? Right. So yeah. So instead of doing this everywhere in your code, you have a computed property. A function that takes in first name and last name. Yeah. That's a bit more expensive. Like you have a function, then you have to pass it arguments. Right. You'd have a function like this. Function full name. It would take in first name. Already, you see all the typing I'm doing? Then it would take in last name, like that. Right. Plus, you got to return something. A string. Right. Plus, you're not done yet. You still have to do the logic here. First name plus last name. Cool? Do the same thing with a closure. What would take the closure? Right? Yeah, like keep it simple. You see what I'm saying? Because already you have your caller passing first name, last name. Well, you have it already. Like the type has first name and last name already. You see me? All what I have to say on my type is, let's comment that code out. All I have to say on my type now is my type.full name. And I'm done. Okay? Same logic we're doing here. So we say return first name plus and this is on your type, all you have to say is fellow.fullname. Everybody with me? So using a computed property there is better, right, than a function. So this is illustration of what a computed property is. We could just comment that out. Sorry. Just comment that code out because we're not using it. But keep it there. All right. So far, so good. So here we have our computed property called has questions. All it does is find out if there's more questions in our array. So far, so good. So far, so good. Okay, cool. What is the next README question asking for? So write the following functions. Write a function to get a shuffled question removed from the question. Wait. Write a method to get a shuffled question, remove the question from the questions array above. Okay, so we have two things to do there. I need to reword that a little bit. But basically, we need to write a function that gets a question, right? All the function, the only task of that function is to get me a question. Return me a question. Everybody with me? Return me a question when I say get question. That's all that method is doing. Let's go ahead and execute that method. Do we have any methods down here? So that was the question here. Let's go ahead and do it. So right where it says methods in your program, go ahead and create one. So we start with the fun keyword. We could call it get question. Get question. Does get question take in any arguments? Or should it take in any arguments? No, right? Should it return something? What's that? Return a question, right? Actually, you guys write the return question part. I have my function, write the return question part, like the logic for return question. So function doesn't take in any parameters, it returns a question. In that way, we have our return and we have question, like that, right? So far, so good. So far, so good. Okay, so this is our method here. Write a method to get a shuffle question. We need to shuffle the array. So our array is called, let's shuffle the array, so shuffle the array. Why are we shuffling the array? Why are we shuffling the array? Would you want to play a game where every time the first question is the same question? Right, that's boring, right? So you want to shuffle the array, so it's always a different question every time. Everybody with me? So here we're shuffling the array. On our array, we say questions dot shuffled. Now we don't want shuffled, because shuffled returns the elements of the sequence. If you wanted to return a shuffled array to something else, you use shuffled, ed. If you wanted to shuffle in place, meaning just take my array and shuffle it, right, without returning anything, I choose the one that says shuffle, that returns void. Do we see that? One returns an array, and one doesn't return anything. The one that doesn't return anything, it shuffles in place. So if I have 1, 2, 3, 4, it's going to shuffle in place 4, 3, 2, 1, whatever it is. Everybody with me? The second option shuffles and returns the array. Yes, sir? You're not getting this? Do you have a questions array, sir? Do you have a questions array? In your property up here. Let me just take that out for now. We'll come back to that later. It's a bit messy. Do you have a questions array here? You do. So it's an array. You could say on that array dot shuffle in your get question function. Right? So here we say dot shuffle. And we're getting the one that says void. Everybody? Right? It shuffles in place. Christian, how you doing? It's not coming up for you. Are you still inside of the struct? Are you still inside of the struct? Make sure you're still inside of the struct. What I mean by that is, or the class, sorry. What I mean by that is double click and make sure your function is inside. Are you inside? Yeah, so be careful there. If you write a function outside of an object, that's a compiler error, 1. 2, you can't use anything else, because that's a compiler error already. Like if I write a function outside of my struct or my class here, function, message, like that, right? It's not gonna work. It needs to be inside of an object. Cool? We don't want to create a new array. We just want to shuffle that current question. The current questions array, we just want to shuffle it before we return a question. Let's go back to it here. Right here. Build. Is this a let? What's happening here? Cannot convert. What is happening? Yes, sir. Can I convert return expression of type void to return type question? Yes.
I have a question. Is there a reason why we use
Dot shuffle here. We're just trying to change. Like we have a current amount of questions. It's always going to be in that same format. So if I want to play the same movie trivia again, it will be the same order. You with me?
Yeah.
You with me? If I play movie trivia, right now our array based on the dictionary we have will be in the same order every time.
Oh, right.
Everybody got that, right? So if the first question asks about something about Star Wars, it will be the same question again. Yes, sir.
What would be the difference between doing that and random element?
You could do random element, but you could do random element, but remember, we still have to do random element. Actually, you could actually just do random element.
Yeah, that's what I.
Yeah. You could just do random element. All right, everybody, right? Does that make sense?
I assume because it's dependent on.
Because it's gonna randomize it anyway. My case, I was gonna use pop last. That's why I went with shuffled.
Okay, so it's both pulling something randomly.
Yeah.
One by one.
Exactly. So different ways you could do it. But yes, you could do random element. It still takes a random element anyway. We'll do that. I think that's actually easier. Yeah, let's go with random element.
So I use Docker to interact between the events.
Dot remove.
Yeah, the Docker remove of the array,
Mhm.
and it just chooses a random number inside the events.
And does that return an optional?
No, it returns a regular.
Okay.
Is it 0 dot dot less than questions array dot count? Random?
Okay. Either way, we could do pop last, we could do random element, but either way, we have to get some random question. Everybody agree? All right, so here we have our questions array. We need a question. So let us do questions array. Let me just show you what shuffle looks like. So shuffle looks like this, and I could say questions here, like that. And I could say questions, return questions dot pop last. Okay. So now that guarantees me to return an optional, because I'm not, the worst case you want to get to, you have an empty array and you try to remove something from it. If you do remove element, Mr. Hat, you might have an error if you do remove element if it's empty. It's going to crash, actually.
So that would only work after this initializer.
It will only work if there's guaranteed to have an element in there, because it's going to remove it anyway. Right? If I say remove element, like if I say remove element like that, let's go back here. Remove or random element or whatever you're doing, random element for example, that's an optional. Dot remove at some index. You need to verify that that array has contents. because it's going to crash your app.
Oh, okay.
All right, so be careful there. So let's go ahead and use pop last and talk about why we're using pop last. We're using pop last because if your array is empty, you try to remove something from it, what happens? It's going to crash, right? So here we're returning an optional. If there's no contents in my array, it returns me nil. Everybody with me? So be very careful how you remove contents from an array. You could guard against it, like is there elements in there? Then do the remove element. You could do that, that's fine. But don't just remove elements assuming there's always an element in there. Everybody with me? So here we'll change our question very lightly. We'll just make this optional. So get question returns an optional question. There could be or could not be any questions. Right? So get question here. Pop last just pops the last element from the array. If there's 4 elements in the array, it pops the last element. Removes the last element. We're just getting a question. We don't care what question it is. I mean, we're just getting a question. We don't care what question we get in. We have to get it and remove it from the array. So pop last does both. It removes and it returns. Cool? If we take a look, yes? The first one didn't return anything. It's void, it just goes in place. And this one returns an array. To illustrate how it returns something to the array. Okay? Let's see what pop last. Right, option click on pop last and let's see the definition of it. So pop last removes and returns the last element of a collection. Do we see that on the screen? Do we see that? It removes and returns the last element of the collection. Right? So far, so good. Okay. So let's see, we did that one here. Write the following methods, we did that. Yes, sir.
Is it setting the output to like a question optional kind of thing? Not setting it output at all? It could be a question, it cannot be a question.
Say that again.
If you were to set the output to like an optional, wouldn't that be the same as not setting anything at all? It could be a question, but it could also not be a question.
So you said remove the optional? Is that the question?
I'm saying, what would setting the output as question, like optional question, do? Like you have an output set.
If we get a question, like in our main that's what when we write it, we'll say, hey, get me a question. And that question could exist or could not exist. If our array is empty, there's no questions, correct?
Okay.
Right? Does that make sense? If our array is empty, there's no questions. We might be able to refactor this later because we have a has more questions computed property already.
So it would either be a question or nothing?
Yes.
Okay.
If there's nothing, our loop has ended. All right, so remove the questions array above. We did that. That removes it, right? So pop last, we said pop last removes the last element and returns it. So that takes care of the remove part of here. Okay, next method, write a method to start the game. This method creates an array of questions. This one, I think I wanted you guys to start attempting it. So here, write a function, call it start. This method basically creates the questions. So let's attempt it for 5 minutes, and then we'll come back to the solution. So write a method to start the game. This method creates the array of questions, because right now we have no questions. We have no questions right now. So start goes ahead and it creates the questions array. Should it take in an argument, a parameter? What type? We have the data already. We have trivia.data. But start itself, like how do I know what array I'm creating? Like is it a movie trivia array? Is it a sports trivia array? Right, so some trivia type, that makes sense, right? So the parameter should take in the trivia type. All right, and based on that trivia type, you create your array. You have to, because remember, if you look at our dictionary, if you look at the trivia type here, if I select if I select sports, I don't want to see movie trivia. Does that make sense? So you want to go through the dictionary and only add, right? Only add the type that the user passed. If the user say, I want to play movie trivia, you want to go through that array and only add where trivia type is movie trivia. Does that make sense? I think I gave us enough fuel there. Brendan? Visualizing. All right. So it would make sense for start to take in some trivia type. Type trivia type. And here, we'll ignore what the external name is. They'll just pass in what the trivia type is. So here we have the function definition. Oh, scroll up like this. Oh, sorry, like that? Yeah? Okay. Yes. Oh, we just want to ignore the external name. Remember, when the user, we just want the user to do something like this, right? Start dot movie type, something like that, as opposed to saying, right? So it ignores the argument name. Cool? As opposed to doing like start trivia type dot movie type. Right? So if we do not have the underscore, the user sees the trivia type : in the function call. And if we have the underscore, then it becomes simpler, like just start movie type. Cool? It just ignores the external name. Lilia, how you doing? Good? Done? Give it a shot, give it a shot. Like that here could be valid for Thursday, right? Like you guys should be able to do this. We've been doing that for like labs and stuff. What am I slacking? How many files? Which one? The game? Game? Okay. Somebody asked me a question. You asked me a question? Game and question. What's that, sir?
Why did we need an argument to start the game?
When I in main.swift, based on what the user enters, I'll start one of the games.
So, as in, like, you'll start with one of the trivia.
Yeah.
Oh,
Yeah, they're not playing all the trivias.
okay.
Cool? Does that make sense?
Yeah.
All right. Question, we did not change question yet today, did we? Yes, we did. Let me send you out game and game. Game. This is a bug. Why don't they fix this? Game. And question, right? We said? And question? Okay. Okay, those two are out now. How we doing? Do we need some direction or are we doing okay? You need direction. What's the first step? Step one, what are we doing? A switch statement. So you switch on trivia. And what does that do for us? Okay. Yeah, we have the movie trivia. We have the trivia type defined. It's the last key in the dictionary. Right, so you look at the trivia, look at the data we have. We have a trivia type here. The key, exactly. That's yeah. You see, you're doing exactly what you need to be doing. Unless you look inside the dictionary. We need to look at the key, everybody. Right? How else can we see? That's why we said object-oriented programming is better than looking at a dictionary. Because now we have to go through a loop. We have to get the key, see what we're looking for. Everybody? Right? So as Chelsea is asking the question, she's solving them herself because she's like, but I have to look in the dictionary. We have to. That's the only way. We need to get the key, get the value, and then compare the value with the trivia type that's coming in. Right? So step one, loop through the array. Which array are we looping through? Trivia data. Looping through question is empty. We have nothing in question. Okay, so here we say for, what are the elements of trivia data dictionary? What are the elements in that array? What element is it? Let's go back to trivia data. Each element is what? What type is it? Each element is a string. Each element of that array is what? A dictionary. Look at our array. This is our array. Each element inside our array is a dictionary. Very important. Do we see that? Right? This here is a dictionary. Right? We have 10 elements, 10 dictionaries. Let's go back to our code for game. So for, we'll say dictionary here, in trivia data. I called my trivia data. So if we option click on dictionary here, we do see it's a dictionary, right? Option click on it. It's a dictionary. The key is a string. The value is type any. So far, so good. Great. So we're in a dictionary, that's good. What else are we looking for? What's step two? Trivia type. Trivia type what? What exactly are we doing with trivia type? You said just trivia type, but what's trivia type? What am I doing with that? The user picked already at this point. Exactly. So what do we need to access in the dictionary? The key. So we need to access the key for trivia type. So access the key for trivia. Well, not access the key, but using the key. Using the key. Using the key trivia type in the dictionary, we need to access the value, right? The value will actually tell us what type of trivia it is. Everybody with me? So you guys go ahead and start doing that. I think that's clear, right? It says using the key trivia type in the dictionary. we need to access the value. How do we access a value in a dictionary? That comes down to that question there. How do we access a value in a dictionary? Any hints? Anybody? How do we access a value in a dictionary? The key, right? Is that value a value by itself or is it optional? It's an optional, right? So you could use optional binding to access the value. So here we'll say if let trivia type equal to our dictionary here. The key is trivia type. Right? Option click on trivia type. It's type any. More work to do. How do we get this to the correct type we need? First of all, what is trivia type in our dictionary? Go to the dictionary. What is trivia type? What type is this? A string. Everybody agree? So we need to go back to our code and do what? What are we doing here? Typecasting, right? Typecasting to what? To a string. Excellent. So here we typecast to a string. Now our trivia type is a string. So far, so good. This is accessing a dictionary. We've seen that 2-3 weeks ago. We use the key of a dictionary. Its value is an optional. So we use optional binding or nil coalescing or force unwrapping to access that value. So here we have trivia type. Great. What are we doing now? What's the next step? Step 3. What's that? Say it again, sorry. Randomly selecting a question. We have a function for that already. We have a function that says get random question. But what we need to do in step 3, we have the trivia type. What are we doing here? Step 3. Yes, Eddie. Very good. So now we need to compare. We need to compare the trivia type the user passed in here. Everybody? The user passed this in, correct? The user selected one of the trivia types. And here we have a trivia type. So we could compare them. Compare them. Is it equal? Is it equal? So compare the user's trivia type with the current trivia type in the dictionary. Right? So at this point, we have enough information to figure out if the current dictionary we're looking at has a movie trivia, if the user entered movie trivia. So far, so good? I only want to add trivia types that the user wants to see. If the user wants to see sports, I should not add movie. Everybody agree? Right? If the user doesn't care, then we add everything. We don't have to do the comparison here. Everybody with me? But my user only wants to play a specific trivia game at a time, which makes sense. So here, we say if trivia type, which is a string, equal to trivia type dot raw value let me make sure all that is correct here. Trivia type coming in here, trivia type here. Value of type has no member of value. 1 second. Let's just rename this for 1 second. So unwrap trivia, unwrap trivia, and our trivia type here is trivia type. We should have our raw value. Did we not add our raw value? Anyway, this is good. So we just renamed this here because Xcode is having some issues, or me. Here we have trivia type coming in, right? That's what the user selected. We have, for now, we have 4 cases, I think, of trivia types. Here we unwrapped our value, right? That's the value we're currently looking at. Is that value equal to the one the user selected? If it is, what do we want to do for step 4? Step 4, what do we want to do if it's correct? If the two of them are matching? What's that? We'll be appending it, append current, or not even append, we have to create, right? So create a question and append to the questions array. Right, so as Amini is saying, if it's correct, we want to append it to our array. But what are we appending? Can we append a dictionary to our array? Right? Can we append a dictionary to our array of questions? Can we append a dictionary to our array? Right? Our questions array takes a question. So far, so good? Right, so we cannot just say questions that append. Look, it's expecting a question already. We can say question append dictionary like that. This does not compile. Right? What can we do? How can we fix this? We're in the question, we want to add it. I want to append this current question I'm looking at to my questions array. How do I fix this? What do I do? With the what? From the key type. At that point, we need like the actual question, like a question type. Questions only works with question type. In that case, we can. It's easier to see or visualize. So let's go ahead and do that. So Amini is saying create a question. I'm not sure if we have that, if we have the initializer yet. That was probably part of the homework. Ah, we have it. Look at that. So here we have a convenience initializer. We created it yesterday, correct? Let's go back and see what that looks like. So go back to your questions or your question.swift file. Go back to your question.swift file. Here we have an initializer that takes in a dictionary. We created it for that exact purpose right now. That exact purpose right now is to say, my questions array, I want to add a question to it, but I need to create a question. I could create a question with a dictionary. We created that yesterday, correct? Okay, very good. So let's go back and do that. So now I have my question here. I could create a question from this dictionary that I have. I have a dictionary here. I could create a question from it using my convenience initializer. Everybody agree? So here I could simply say question takes in a dictionary, pass in it a dictionary. What do I get back? I get back a valid question. It's optional. That's fine. We know how to work with optionals. Right? So one more step. Step 5. Unwrap question and add to array. So here we simply say if let question exist. If it does exist, just go ahead and append it. Go ahead and append it to my questions array. Let's see if we can get the whole function. Yes, we can. We got the whole function on screen. Almost. Which one? This one? Oh, it was a bit, I guess the compiler wasn't really seeing the difference yet. So we just renamed our trivia type, optional unwrap there, to unwrap trivia. Cool.
So right now we're not creating, from what I understood, was that we were creating the entire.
Oh yeah, that's fine. Again, you have to ask those questions. Like, are we creating the entire array? No, no. We're creating based on what the user entered. Cool? Do we see the entire function? Yes, we do. So here we have our start function. It takes in a trivia type. We go through our dictionary on line 48. We look through the dictionary, or we look through the array, sorry. We look through the array. We look for the key trivia type. We look for the key trivia type, right? It could or could not have a value. There's a possibility there. It's a dictionary. It returns an optional regardless. Here we have unwrapped trivia, right? It could be so far movie, sports, music, or NYC trivia. So far so good? One of those four options could be that unwrapped trivia. We take the unwrapped trivia, we compare it against what the user wants to see or play. If the user wants to play movie and this is movie, awesome. We add that to our array. If it's sports, do we add sports? If the user wants to play movie, do we add sports? No, we don't, because that's not equal. Sports is not equal to movie. So we skip it. We go to the next dictionary. So far, so good? So we go through each of the 10 elements. If it's equal to what the user wants to play, we go ahead and we append it to our questions array. Okay? That's how we get our correct array populated. Yes? Yes, we do. Make sure it says, go back to your trivia type and make sure it says, Chelsea, here, make sure you have colon string. Build, do Command B. It could be Xcode or just, yeah. Command B. What's that? Say that again? This is not returning anything. It's not returning anything. Because the question now, the game owns question. The game class, Luba, the game class owns questions. It has questions now. Because maybe you have a return here. Do you have return here after, so just remove it. Okay, cool. I think we have one more to do before we test this, because I want to test this. We'll take a break and then come back. In our what's that? Yeah. In our trivia type, not trivia type, sorry. Where did we change this? In question? In question, we had a to-do yesterday, right? Because here we have a warning. Go back to your question.swift. Everybody go back to the question.swift. Right? Who was able to solve this? It says to do, create a fillable. Well, we did that. So I guess we could take out our to do here. Right, so we created our initializer here. But we had a next to do. Get a valid trivia type from the enum to add to the designated below. Because this here, we only have movie trivia. We needed to fix that. Who was able to fix it yesterday? What was that? Yeah, we did raw value, but here we have to actually do some more code to fix that. Just change this to trivia type. Like that. All right. Amini, come up and fix this for us, please.
No, we can,
Don't know if you can.
but I shall try. So it's trivia type. We're referencing the raw value, but I don't remember how.
Oh, you want to create a type, right? So it's uppercase E.
Oh, wait.
So a meaning is using the trivia type
Is it
type
not raw
to
value?
actually instantiate a raw value, or using a raw value to create a valid type. here she's passing in trivia type.
And then it's gonna be.
We have trivia type, right? No, we don't.
I don't remember.
You don't have access to it. It's over here.
Oh. Oh yes.
So maybe make it a var.
This.
Yeah.
Oh yeah.
1 second. Maybe take that out here. That's one way to do it. And make this guy a var here. Trivia type equal to string, right? Trivia type.
But isn't that already what we casted it here as?
You cast it here, but you have no access to it. You see what I'm saying? Here, do it again. You have trivia type here, right?
Okay.
It's a let. So far, so good,
Mm-hmm.
right? If you have trivia type here, this is fine. It's valid,
Okay.
right? But here, you need access to your trivia type to create your new array. Do you have access to trivia type here?
No, because it's.
Solved it yesterday.
I did, but
How did you do it?
I forgot how to use the raw values and.
Okay, that's fine. You will never take a computer and come out.
Do I have to come back?
No, that's fine. I got it. Cool. Thank you, Amini. Okay, so there's a lot of moving parts as always, right? So what we're trying to do here, yesterday we stopped. Let me go back to what we had yesterday. Okay, so yesterday we used our convenience initializer. We created all our properties, but this last property here had a warning. It had a warning, it was a string. We were not able to use it on our trivia type here, right? So what Amini is trying to get to is creating a trivia type using the raw value initializer, right? So what we need to do is replace our hard-coded movie trivia because we don't want to create all movie trivias. Everybody with me, right? Because regardless of what the user puts in here, we have movie trivia, which is hard-coded in there. That's where we stopped yesterday. To fix this, we need to create a trivia type using the raw value of trivia type, which we have, like that. We still have to unwrap it, very good. And in that case, we'll give it some default value. We'll give it some raw value here. Sports. Build. And let's walk through that code again. Trivia type expects a trivia type enum. We have a string. That doesn't work. Everybody with me? Right? So here, if you pass in a string, it doesn't work. And we need our custom type. So far, so good? We need our custom type. We cannot create our custom type here, where it says string. I can't put trivia type there. That's going to fail. My dictionary doesn't have a trivia type in it. It has a string. So far, so good. That's where we stopped yesterday. So here we have a string. We capture the string, whatever it is. It could be movie trivia, sports trivia, NYC trivia, but it's a string. So far, so good. My initializer expects, if we go back to it, it expects what? A trivia type, not a string. Do we agree? So we need to do some conversion here. We need to go back to our designated initializer, use our trivia type, enum, the name of it, use raw value, instantiate it with some raw value. The raw value should be what type? What's our raw value type? Look at our trivia type again, and please tell me what's the raw value. Please, go to, look at the code. What's the raw value type? Luba. It's a string. Very good. So our string, this is valid because here trivia type is a string. So far, so good. But I could put in any string there. That's why it returns me an optional. That's why we need to use the nil coalescing. Because I could try to use some trivia type string that doesn't exist. right? Currently, we only have 4 valid strings that exist. Everybody with me? So that's why the raw value initializer returns an optional. And that's why we need to use nil coalescing. We need to unwrap it. Because right now, our trivia type is not optional. We could easily not unwrap this by making it optional. But we know how fun it is to work with optionals, right? Don't worry, there's optionals coming. There's more optionals. So the more optionals you have, the more unwrapping you have to do. But if I have an optional as trivia type here, which probably would not be valid, like why should I have an optional? Maybe I do. Maybe I don't care what trivia type they are. So this could be an optional, and I wouldn't have to nil coalesce it. So far, so good? But here, it's not an optional, so I have to nil coalesce it. So understanding that code here, how to do it, actually do it again. So before we had like movie trivia, go back and create raw value from the trivia type. And make sure the warning, when you create it correctly, that warning will go away because now you're using trivia type. Everybody with me? So if you go back to the code yesterday, there's going to be a warning, meaning you're not using the property yet or that variable. Update this by using the trivia type and a raw value initializer and pass that raw value trivia type. So far, so good? So the code we just did, basically you're doing it again. Question? Question? Oh, I'll come. We know what we're doing, right? We're basically typing in the code we just did for muscle memory there. Like what we just did, we just created a trivia type from a raw value. So here I could just put some notes. So creating a trivia type using the raw value initializer. Do we need to select something? What do we need? The game? I'm in question right now. What do we need? Oh, it was screaming at you. Oh, call me if that happens, right? Like, just stop me. We know what we're doing, right, everybody? Chelsea, we're going back to the code I just wrote. We're writing it ourselves. So instead of saying that movie trivia, we're saying trivia type, parents, raw value, and we're passing it trivia type. Everybody knows what we're doing, right? Shania? Yulia? Lilia? Yulia? Lilia? Oh, I didn't go back. Oh, this one is just pretty gay. It should be. I don't know what. In the dictionary, we don't have a type for it. It's going to fail. It's not going to fail. Leave it there, it's going to fail. Yeah, exactly. Exactly. So then this is string, and then, yeah. All right, let us do it again, and then we'll take a break. Okay, so yesterday again, we left the code like this, and your task was to go and fix it, meaning to create a trivia type here, as opposed to what we're currently doing. Because as we see the code currently, every trivia type will be a movie type. So far, so good. This is not good, right? Our code is broken. So what we need to do is take in this trivia type here, which is a string, everybody, and use that string to create a true trivia type from what the user or what the dictionary has. Everybody with me? So what we do is we remove that movie trivia here. We start out by the name of the type. It's called trivia type. So far, so good. This is an enum. We could create an enum if it's a raw value from a raw value. If you say your enum accepts a raw value, right, you could create a case or an instance of that enum using the raw value initializer. So far, so good. So here, our raw value expects what type? A string. What type is trivia type here? A string. So those all are compatible. So here, I will put in trivia type and build my code, make sure I have no errors. I have errors. What's the error? The error is saying it's an optional. It's an optional, I can continue. Why? Because my trivia type in my initializer here is not optional. So far, so good. If I made this optional, my error would go away. But there's other errors that come along the way, right? So here, it's not an optional, so I need to go back and unwrap it. In our case here, we said we'll unwrap it by giving it a default value. So here, I'll say trivia type. You could give it any default you want. We'll just say sports trivia here. And build again, Command B. At that point, our convenience initializer is done, right? So far, so good. So far, so good. All right, cool. So let's test this and we'll take a break. So any questions with the question.swift file before we move on? Are all question.swift files working? Yes, sir.
Maybe one more thinking, but doesn't the convenience initializer protect us against returning a nil value?
It protects us, but what exactly are you asking? It protects us from returning a nil. That's fine, but the protected meaning your object is not going to get created.
Right, so then wouldn't self underneath that?
The designated initializer here,
Yeah, wouldn't that not kick off at that point?
if it returned nil, yes.
But we still need to coalesce.
That particular type here, because that type is not an optional. Like remember, if you look at 1 second, that's a good question. Let's go back up on why we're doing this. So in our property here, Greg, our property, trivia type, is not optional. Is it optional? It's not. So I cannot leave it with an optional. The compiler will scream at me. Right? This needs to match. A trivia type here is not optional. When I assign it as an argument, that argument itself cannot be optional. Is that fair? Let me show you very quickly. So if I have, let's just create like a simple, let's create a simple struct here. So struct, you guys don't have to type this out. So struct fellow, for example. Struct fellow has an age. It's an int. So far, so good. And I say I want to create a fellow. I want to create Greg. Well, that's not going to work in here. Let me go to, again, just keep your eyes up, please. We're not writing that code out. So I'll create a struct here. And I will create an instance of my struct Greg, who is a fellow. So far, so good. And I'm saying I want to pass an age. Is age optional? No. So I go ahead, I say I want to do this. Right? At that point, the code is not going to work because my property is not an optional. But I'm trying to pass in an optional here.
I see, so it's going to protect the user from entering something that might be incorrect data.
Yes, yes, exactly. It's like passing a string and then you expect an int. Two different types.
I was thinking about like within the block, but this is going to go a little bit beyond.
Yeah, because if you, again, it's a function. Again, if we write a function here, please just pay attention here. This is very important. So I could have a function here to take in whatever. Function, this info, whatever. Info takes in a string, right? Info takes in a string. That's good. I'm just going to print whatever I got passed in here. Type in string. And if I call in, let me comment this out. If I call my info, well, let me get Greg working. So get Greg working validly. Pass in the age here. Cool, so Greg is valid. And on the instance of Greg, I say info. And I pass in some info. I pass in some info like this. Right? Again, what type is my function parameter expecting? A string. What type am I trying to pass in here? Chelsea, what type am I trying to pass into my info function? What type is this? It's an optional. What type am I expecting here? Regular string. So that's not going to work. Everybody with me? This is very important. If your function is taking an optional, you could pass in an optional. You don't have to unwrap anything. If it's expecting the concrete type, you have to unwrap it. So that's why on our trivia type, we have to unwrap it. Because the property itself is not optional. Do we get that? Julia? Yeah. Errors we'll fix like right at the break. So this was just to show us what's happening here. Let's take all that out and test the code, and we'll take a break and we'll fix errors. So far, let's go back to our game. Do we all agree and we all okay with the question so far? So Greg's question was, why do we have to unwrap? Why do we have to unwrap our trivia type? We all understand now, correct? Our property is not optional. We cannot return an optional. Or we cannot instantiate our object with an optional. So far, so good. All right, great. Optional, fine. Concrete type, fine. But you can mix them. So far, so good? All right, good? Yeah. So let's go to our game. Yes?
I understand the uniform part, but I don't understand the sports.
Remember, you have to give it a default. When you do nil coalescing, you have to give it a default. Good question. All right, so let's test this out. And how are we going to test this out? We'll just print it at the bottom. So at the bottom of your for loop, write a print statement that simply says, questions that count was created. At the bottom of your start function, right, outside the for loop, right, not inside the for loop. We don't want the thing to happen X amount of times. We simply want to happen after the for loop. So after the for loop, inside of my start function, my start method, simply put a statement that says questions that count was created. After the for loop, inside the function, after the last curly bracket in the for loop. We're just testing now. See how many questions we have. What happened, Chelsea? Just with what we did here now? Oh, okay, I'll come to that. We'll come to that. How are we doing? We good? So we have that one print statement. So far, so good. Okay, let's go to the main. Let's go to main.swift. Create an instance of game. What type of method is start? Is it an instance method or a type method? Stephanie, what type of method is it? Instance, right? So it's an instance method. We have to create an instance of game to use it. So far, so good. So far, so good. So here we create an instance of game. So let game equal to game. And as I said, always get in the habit of Command B as you're writing code. Don't write 20 lines of code and then Command B. Always build as you go. You don't want to get to 30 lines, build, and then you have 10 errors. That's like frustrating, right? It's missing argument for like in the question that append. I'll come to you like right during break. So let's have our game here and simply do game.start. Everybody, game.start. And we could put in any of the valid trivias we have here. So game.start. I'll just do movie. You could select any one you want. And at this point, Command R, run it. Command R. Look, I got 5. 5 was created. I forgot to put questions in there. But 5 was created. Let me update this. So 5 questions. 0, that's fine. We'll fix the 0. If you're getting 0, something broke on your initializer. So build again, run again, sorry. So here, 5 questions were created. So far, so good? We getting zeros? Go back to where I printed out the statement. Okay, I printed out the statement in the game, in the start function, right? Look at the start function at the end of the for loop, not inside of the for loop. Matt, did you get the questions? Okay. You see it? So right at the end of the for loop, outside the for loop. If you did that, did it print anything? Okay, that's fine. That's fine, meaning there's an error in your initializer. We'll come to it. One of the things went bad, so it never created that. We'll go back to that. Okay, everybody okay here? So that's where the print statement goes. So far, so good. Let us first make sure that your initializer is valid. We'll verify initializer is valid, and then we'll verify you actually add in the start. Those are the 2 places we have stuff happening right now. So far, so good. So let's go back and debug. Debugging is fine here. So let's go to our question initializer. Take out that to do, sir. You are done with this. Go back to our question initializer, this one. Right. So let's make sure that we have everything correct here. Let's talk about it. We started off with creating the convenience initializer. So far, so good, Cassandra? We said we guarding against all the properties or all the keys of the dictionary. Make sure, that's why we need to start making sure things are correct. Make sure question is question, like you're not like question or something. Make sure it's spelled correctly. Question. That's good, right? As string. That's step 1. Step 2, make sure we have correct answer here, camel cased. Lowercase c, correct answer. As string. So far, so good. Third, we have choices. Is choices spelled correctly? Is it also casted to a string? Fourth one, yes? Always want to take it a step up. You see that? She wants to refactor all our code. Make choices an enum, which is fine. But some people are going to start pulling their hair out and like stabbing me. So let's get it working first, and then you could refactor. Cool? But that's good. That's good that you see the choices, maybe make it an enum. But we'll get there. Okay, so choices is correct, right, Cassandra? Next, we have fact. Is it fact as a string? Yes? No, but that's not going to work. The key is facts. Is the key facts? It's not going to work. Now let's stop there for a second. Why is it not going to work? Let us stop there for a second. Good point there. Not point, but good observation there. We're debugging our code. Are the keys correct? Remember we said the keys need to exactly match the keys in the dictionary. So now Cassandra has facts, plural, as opposed to fact. Let's see what our dictionary looks like. Look, what do we have here? Fact, singular. So far, so good? If we have facts, what happens in our initializer? And what happens? It fails. It fails on every single one. And what does it return? Nil. So nothing ever gets created. Everybody with me? Right? Because we wrote our initializer such that if any of the keys are missing, do not create a question. So far, so good. It's good that we're able to see it and debug it real time. This is very good. So at this point, you should get your questions. Very good. Anybody else getting 0? Okay, so let's continue. So we've gone through all that 0. All of them correct so far. Let's keep going. Trivia type is trivia type. Camel case, a string, and else return nil. So far, so good. We went down, we said call our designated initializer, pass it all those values, right? But stop on trivia type because we can pass it a string. So far, so good. And we said trivia type, access raw value, make it a trivia type. So far, so good. And nil coalesce it to a default value. Okay, so at that point, our convenience initializer is tight, it's solid, it's working. Let's go to our, what's that? No, that's fine. Let's go to the next one. What's the next culprit here? Let's go into the game. Let's go inside the game. Let me move my game. My game should just be right down there. Let's go to the game. The only thing we're using right now is start. We have a start method. So far, so good? 0. Start. We have a start function. You don't have a start function. Okay. So you have a start function. It takes in a trivia type, right? We went to our dictionary here. We're going through an array. So far, so good? It's called trivia.data. That's an array. If you option click on your dictionary here, it should show string colon any. Option click on it. Option click on it. On the variable name. String any, correct? Okay, good, perfect. Next step, we said let's go ahead and access trivia type key. Make sure it's trivia type like that. Right? As string. And we went in here, we said if the value that I just unwrapped equal to the one that the start function passed in or the user selected, if they're equal, come in here, create a question from our convenience initializer, right? And append that question. So far, so good? And at the end of our for loop, outside our for loop, we put the print statement, questions account. Right? And in your main.swift file, you created a game. You created a game, and you called the start function, and you passed it some trivia. So far, so good? All right. At this point, I'll come to your screen and see what's going on. But we have gone through all the steps necessary to make it work. Everybody else, anybody else have a problem?
I do have a question. So, from where you have a question here, this is from, you said from our convenience init, right?
Which one? What am I looking at? What file?
All right, so for the game, right, we have input question, equals to question, dictionary.
This guy, 51?
No, 59.
59.
Right?
Where we actually create the question from the convenience in it. What's the question?
Okay, so the way that you got question was from function get question. That's the question. When you said
We haven't used get we haven't used get question.
right, but so the question here, we're saying that question equal.
This is unwrapping the question coming back. Remember, our initializer returns an optional.
So this is not going to be the value that we use for. Sorry.
I think you're jumping ahead a little bit.
No, it's not going to be the what we did. This.
We haven't used get question function. This is only working on creating the questions based on what the user entered. All right, so at this point, let's stop and take a break. We'll come back.